and I'm going to share this, share my screen, and I'm going to bust out the code and the whiteboard. And I don't know why. Why is this? Hold on 1 second. One second. Let me stop the video. So, all right, cool. We're still recording though. I'm going to share my screen. Okay, cool. Here we go. Why does this stay here? This bar hide self view. I don't know. Okay, cool. That's fine. Okay, so we have this whiteboard, right? Let's think about let's go over what a queue is, right? A queue, it's just it's first in, first out, right? It's like a line, right? Think about a line. That's what a queue is, right? So think about a queue, and I would recommend right here. Let me refresh this whiteboard here. Is it really doing that right now? Okay, cool. So we have this whiteboard. So right now we just have all this code here for the class Q that we went over from Monday, right? And let's just say right now, none of this code works yet. Even this contains, right? I'm gonna comment that out for now. But let's create a queue first. All right, let's create a queue. To create a queue, I'm gonna call the class Q. Let's call it Q1 equals 2. I'm gonna call the class Q. Cool. I called the class Q to create a new queue, and it has two parameters. I mean, not parameters. It has two attributes, head and tail, right? And they're both equal to none. So let's represent it on the whiteboard. Q1, that's our queue, right? And it has a head pointing to nothing and tail pointing to nothing upon initiation, right? Upon initialization. Cool. And then what can we do? How can we add things to a queue? Q1.enqueue, right? And if you don't remember how the enqueue method works, please check out Monday's video. But Q1.enqueue, when we call the enqueue method, we got to pass in something for value. So if I wanted to pass in, right? Let's just say there's different numbers in line, right? 3, right? Q1.enqueue 3.enqueue 5 5.enqueue 8, right? So let's think about it. In a line, right? The first thing that entered the line is a node containing 3. Then we have a node containing 5. Then we have a node containing 8, right? So that's the order. So eventually, our queue will look like this. Oops. Our queue will look like this. It'll have a head, and then it'll have a node containing 5. Node containing 3, my bad. Node containing 3, node containing 5, and then so it's 3, 5, and 8. Okay. So that's what the Q1 looks like. And the method that we're gonna do here, right? That we're trying to do here is called contains. So that was the algorithm for today, right? Contains. So I want to be able to call the dot contains method on Q1. Like if I do Q1 dot contains 7, right? It's gonna see if the value 7 is in any of the nodes in Q1, and if it is, it's gonna return true. Otherwise, it's gonna return false, right? So in this case, what do you think it would return if I were like, let's say this code works, the contains code works, right? So ideally, let's say the contains code works. We have the solution there. What would it return if I try to see if it contains 7? Would it return true or false?
It will return false.
It would return false, right? Because the number 7 is not in any of those nodes. Cool. And if I were to do, if I were to say dot contains 5, it would return true because there is a node containing 5 in this queue, in Q1. Cool. So that's the basis for that. So how would we do that? Well, let's look at it how we look at it through our eyes, right? Well, how do we know that if I were to do Q1 dot contains 5, how would I know that how would I know to return true or false if I just looked at it, without any coding? Well, I looked at each node to see if there's any node containing 5, right? So if I want to look at each node, what's a good variable that we can create if I want to go through all the nodes in a list?
Runner.
Runner, cool. Yeah, if I want to run through all these nodes, right, I can create a runner, right? So let's create a runner, and runner equals 2, and I want to start it at the beginning of the line, right? So I want to start it from the beginning of the line, and I want to say, hey, is there any value in this line that matches the what we're trying to look for, right? So what represents the beginning of the line, the front of the line?
Self.head.
Self.head, awesome, cool. Runner equals to self.head, awesome, cool. Runner equals self.head, and that line of code, right? If I were to translate that into the whiteboard, what that would look like is I have R pointing self.head, right? Cool. So that's what we have. And then I wanna check, as long as runner is pointing to a node, I want to see if the value that the runner is pointing to, I want to see if the value at the node that the runner is pointing to is the same as the value that we're looking for, right? The value that we're looking for is 5, right? Let me actually rename this parameter to value we looking for. Okay, I'm just gonna make it really explicit, just to really so we can we don't get confused with the word value from the node value. Okay, I don't want to get you guys confused with that. Cool. So 5, when I do q1.contains 5, 5 will be sent in for 5 will be stored in this parameter value we're looking for, right? We're looking for the value 5, and if we find it, then it's true. If we're not, it's false, right? So while runner is pointing to a node, while runner does not equal to none, right? While runner does not equal to none, while runner does not equal to none, right? Right now, where runner is at is runner pointing to a node object?
Yes.
Yes, it is, right? So runner.value is what?
3.
3, right? So I'm going to say if runner.value is equal to the value we're looking for, right? This variable value we're looking for. And in this case, what does this variable value we're looking for storing? What is it storing right now? In this case, if we do contains with 5.
The value we're looking for.
Yep. What value is it storing? If we call q1.contains and we pass in 5, right? What is this variable value we're looking for is storing? What number is it storing?
Oh,
5.
5, right? And then runner.value is currently 3, right?
Yep.
So if runner.value is equal to the value we're looking for, then we're going to return true, right? But in this case, it's not, right? Runner.value is 3 and value we're looking for is 5. So it wouldn't hit this if statement. But if it did, we'd know that, hey, we found it, so we could return true, right? It's like let's say if I did contains 3, right? q1.contains 3, then hey, while runner does not equal to none, while runner is pointing to something, if runner.value is equal to the value we're looking for, well, yeah, we found it. Then we can just exit the function, we can just return true, right? But let's say if it wasn't 3, if it was 5, right? Then what would we do? Well, we didn't find it, it wouldn't hit the if statement. So I need to get runner to get to the next node, right? So if I want runner to get to the next node, I want to increment runner, right? This is how we increment runner, okay? Runner equals to runner.next, okay? So that's what we're gonna do. Runner equals to runner.next. So what this line of code does is I'm gonna be like, okay, I didn't find the value we're looking for where the runner currently is, right? But we haven't searched the whole list yet, so let me increment runner to get to the next node in the list. Okay, so I'm gonna set runner to equal to runner.next. What that does is now I'm gonna move runner to point to this node now, right? So now I have incremented runner, and then we evaluate the while runner does not equal to none. Well, runner's pointing to a node object now, right? Runner's pointing to the node object containing 5. So runner.value is going to be 5, right? And value we're looking for, well, it's 5 from the contains function, right? Right here. So if that's true, if we find the value, like it's going to hit this if statement, right? then it's going to return true. Cool, it works. It works for that situation, right? But let's say if it wasn't 5, right? Let's say if it was 98, right? Then it wouldn't hit this if statement because runner.value is 5 and value we're looking for is 98. So this if statement is not going to hit. Then we're going to increment runner to see what the next node has, right? So we're going to increment runner. Now runner is in the next node right here, in the last node, right? So that increments runner. And then while runner does not equal to none, well, runner is not equal to none. Runner is pointing to a node object, right? And by the way, this last node has a arrow coming out. Okay. Runner is pointing to a node object. Cool. If runner.value, well, if runner is pointing to the node containing 8, runner.value is 8. And then the value we're looking for is 98. Well, that doesn't hit, right? That if statement wouldn't hit. Then it would increment runner to equal to runner.next. Well, now when runner increments to runner.next, runner is going to be right here now. Now what is runner equal to now?
None.
None, right? So can this while loop run anymore?
No.
No, right? So if we finish the while loop and if we never ended up hitting this if statement, that means we went through the whole while loop and we never found a time when the runner value was equal to the value we're looking for. So if we finish this while loop, that means we never found what we were looking for. So we can return false, okay? Cool. Let's test this in action. I'm gonna have it print this function call. Let's see if it returns false for us. Where's my terminal? Python q.py returns false, right? Let's see if we look for the value 8, it should return true, right? Because the value 8 is in the queue, as you can see, right? Cool, it returns true. Okay. Awesome. And one thing for tomorrow, right? Notice how we have the dot size method available, right? If you don't remember how we did the dot size method, it's on Monday's algorithm solution video, so please check it out. But if I were to do q1.size, if I were to print q1.size, right? It should print me 3, right? Because there's 3 nodes in the list. Just remember that you have this size method available for you, okay? We're gonna need this tomorrow for tomorrow's algorithm, okay? And you're also gonna need, you're gonna need the size method and you're gonna need the enqueue and dequeue method, okay? So review over those methods in the, later tonight from Monday on queues, okay? And on stacks, let's do these 2 methods, right? Size and contains. Okay. Let's talk about a stack though, right? So let's talk about a stack. What would our stack look like? Well, a stack is, think about a stack. In a queue, it's first in, first out. FIFO. Okay. First in, first out for a queue. For a stack, it's last in, first out. Last in, first out. LIFO, okay? So think about a stack like the way the back button works on your browser or the undo button works on your keyboard, right? That's how a stack works, okay? So, or think about like a stack of pancake, like those are applications where you can see in examples of stacks, right? The back button on the browser, undo button. But also think about like in terms of conceptually, think about like a stack of pancakes, right? When you, let's say I have a plate here, this is my plate. And then I put a pancake down. I put a pancake down, that's the first pancake I put in, let's say pancake number 1. And then the next pancake I put in, it goes on top of the stack, so pancake number 2, right? So the top is adjusting, right? The top of the plate is now pointing at pancake number 2. If I insert a new pancake, I'm inserting into the stack. Well, top is no longer pancake number 2, right? We want to adjust the top to be pancake number 3, right? So that's a stack, right? And now let's say I was to remove something from a stack. Well, the first thing I can remove is the thing at the top, right? So I can remove the pancake number 3, right? And now the top would represent pancake number 2. Okay, cool. That's just the concept of a stack. So last in, first out. Okay. Right now we have no stacks here, right? This is just some class stack and class node. None of those classes do anything until we use those classes to create something. So let's create a and let me comment this out, and let me comment this out for now. So let me create a new stack. stk1 equals to, and I'm gonna call it stack class. Cool. So when a stack gets created, what does it get initialized with? Just one attribute, self.top is equal to none. So stk1, this is what it looks like. It has a top that's pointing to nothing. Okay. And then if we run the push method, right, we can add things to a stack. That's how we can add things to the stack. So stk1.push, and when I do push, I need to give it some value to add to the stack. Let's say I want to add pancake 1, right, or something like that. I can add strings too, by the way, but let's just stick with numbers for now. I don't want to get people confused. Let's just say I add 5 to the stack, right, and then I do dot push again, and then I add 8 to the stack, right, and then I do dot push again, and then I add 3 to the stack. Okay, so what should this look like? Well, think of this. This is the first pancake in the plate, push 5, right? And then this is the next pancake I put on top of that first pancake, and then this is the next pancake I put on top, right? So it should look like the stack. It should look like node containing 5 is the first thing that's put on, right? And then the next thing that's put on is going to be on top of it. So node containing 8, and then a node containing 3. Okay, and then the top should be pointing to the node containing 3. Okay, this is what it would look like after doing the push, right? So so this has 3, 8, and 5. Well, let's do the size, right? What if we do stack1.size? What do you think it should return? Let me actually push one more thing. Push 23. Okay. So if I do dot push 23, let me actually move this down here a little bit. Oops. Undo that. Why is this whiteboard app is a little bit weird sometimes? Hold on, let me redraw this out. It was 5 was at the bottom of the stack, right? And then 23. Okay, cool. So this is what we have so far, right? The top is pointing to the nodes containing 23. So if I were to do stack1.size, let's say the size method works properly, right? What should it return?
Should return 4.
Size should return how many nodes are in the stack, right? So there's 4 nodes in the stack, so it should return 4, right? Cool. Let's make it so this size method works. Right now, I can't call the size method because we haven't even defined it yet. So let's define it. Cool. And if I want to know the size, well, what do we have to do visually without coding, right? Well, we started from the top of the stack and we counted how many, right? If you wanted to know how many pancakes you got on your plate, you look at your plate, you're like, okay, 1, 2, 3, 4. You start counting, right? From pancake to pancake. Every time you see a pancake, you increase the count by 1 in your head, right? So we start with the count being 0. Count equals to 0, right? And then we're gonna start we're gonna start from the top of the stack. So if I want to start from the top of the stack, I can set runner to equal to self.top, right? And that's what, and in the whiteboard, as you can see, the runner R is pointing to where the node containing 23, that's where the top is, right? And then while runner is pointing to a node, I'm gonna increase count, and then I'm gonna move runner to the next node, right? So while runner does not equal to none, while runner is pointing to a node, that's what that means. I'm gonna increase count by 1, count plus equals to 1, right? Because right now I see at the nodes containing 23, I'm like, okay, count, that's one node. And then I want to go to the next node, right? If I want to go to the next node, I got to increment runner. Okay, cool. Okay, and then it increments runner. So let's see what this would do, right? Count is going to start at 0. So let's just say we have 0, right? And then let me actually redraw that a little bit neater. Count equals to 0, right? And then runner equals to self.top. So we have runner right there. And then while runner does not equal to none. Well, runner is pointing to a node object. Cool. So it's not equal to none. That's true. So increase count by 1. Okay. So count now becomes 1. Count is now 1. And then increment runner so we can get to the next node. Okay, cool. Runner is going to go to the next node. Okay, cool. And then we're going to evaluate the while loop. While runner does not equal to none. Well, runner is pointing to a node object. So runner is not equal to none. This is true. So we're going to increase count by 1. So now count becomes 2, right? And then we're going to increment runner. So runner goes to the next node. Right? And then while runner does not equal to none. Well, runner is pointing to the node containing 8. So it's not equal to none. That's true. So increase count by 1. So count is now 3. Okay. Count is now 3. And then runner equals to runner.next. So increment runner one more time. Okay, cool. And then we evaluate the while loop. While runner does not equal to none. Well, runner is pointing to the node containing 5. So runner is not equal to none. That's true. So we can do the code in the while loop. Count, increase the count by 1. So count is now going to be 4. And then increment runner to get to the next node, right? Runner equals to runner.next. Well, the problem is, well, it's not really a problem, but the thing is, there's not really a next node. But when runner goes to runner.next, it goes to where the arrow that's coming out of 5 is going to, right? The arrow that's coming out of 5 is going to. Runner's going to point to that. So we have runner pointing to where this, right there, right? So now runner is equal to nothing. So while runner does not equal to none, we're going to do this stuff. But runner is equal to none, so we can't do this while loop anymore. So that means we have gone through this while loop. By the time the while loop is done, runner has gotten through every node in the list and incremented the count. And now by the time the while loop is done, I can return counts. Right? So if I were to return count, so stack 1.size, if I want to see it in the terminal, I can print it. Print stack 1.size. Let's see what that gives us. It should give us 4, or it gives us 3. It gives us 3. Why does it give us 3? Oh, okay. So while runner does not equal to none, increase count by 1. And then runner equals to runner.next. That should have given us, why does it give us 3? Oh, this is q.py. I'm running the wrong file, right? I'm running q.py. So this file is stack.py. That's why.
I actually have a question on the Q one when you did size.
Uh-huh.
Because I was basically copy pasting that code, and I said to myself, why isn't the while runner on that one? While runner is not equal to none?
And while runner, well, that's another way to write that down, right? While runner is the same thing as saying while runner does not equal to none.
Okay.
So while runner exists. So while runner does not equal to none. Another way a short way to write that is this, while runner.
Okay, so it's implied.
Mhm.
Okay.
Here, I'll just make it more explicit than implicit. And in Python, they say explicit is better than implicit. So there you go. Cool. And now if I were to run stack, yeah, it returns 4, right? It gives us the proper amount. Cool. And contains, I mean, it's the same thing. It's the same process as we did here, right? Instead of runner equals self.head though, it's gonna be runner equals to self dot. There's no self dot head in a stack, right? There's no self dot head, there's a self dot top, right? So we're gonna start from the top, right? And then while runner does not equal to none, if runner dot value is equal to the value we're looking for, return true, otherwise increment runner, right? So that's the same exact code. So I don't want to re-explain it twice. I don't want to run out of time here. It's 11 o'clock. But let's just print stk1 dot contains contains 5. It should return true, right? Because it does have 5. So let's see. Okay, we get an error. Value we're looking for is not defined. What do you mean? Oh, this is supposed to be value we're looking for. Okay, cool. Cool, it returns true, right? And then if I do dot contains 15, well, it does not have 15 in the stack, so it should return false. Cool. Okay. We can have a Q&A session for like 5 minutes, and then we can take a little small break. Okay, cool. Well, if there's no questions, let's just get on with the program in 10.
I had a question.
Yeah, you had a
I put
question?
it in the
Okay.
chat. Yeah,
Oh,
I
you
put
put it in
my
the chat?
question in the chat.
I'm sorry, I didn't see it. Hold on one second.
Sorry, no worries. I was gonna wait till the break.
Oh, I got you. Let me stop the share for a second. I have a question. Enqueue and dequeue functions. My enqueue function stops working after I call dequeue in a string. Any ideas as to why this is happening?
I'm finding that any function that I call after DQ doesn't work.
Okay. Can you share your screen?
Sure. Yep.
And if for anyone else that understands that doesn't have any questions, you can feel free to take a break. We'll start at 11:15 Central Time. I mean 11:15 Eastern Time, 10:15 Central Time.
Rob, can you throw the contains method from the queue into the walkabout?
Yeah, I can give you guys all the from everything.
Thanks.
All right. So.
1 second, Natasha, before I forget
Sure.
to post the code.
Thanks, sorry, Natasha. That way I can play with it.
Okay, so that's for the stack. I just sent the one for the stack with a solution. Let me send the one for the queue with a solution. Okay, I just sent the solutions for stacks and queues. So you should have everything from this week so far on the walkabout. And go ahead, Natasha, what's your question?
Yeah. So everything here, as you can see, is working. I put it I ran it in the terminal, works as it should. As soon as I add the queue, wait, let me actually spell the queue properly. As soon as I add the queue, I get an error.
None type. Okay, I see why that is. So right now you're trying to chain methods, right? Remember chaining?
Yeah.
So you did dot display, dot dequeue. So you can only chain if you're going to return self. So display is not returning self right now.
Okay.
So you can only chain if display returns self. So can you have display return self after the while loop is done?
Okay.
Okay, cool. Let's see what that looks like now.
Huh. All right.
Okay, cool. And
Just
then
wanna
maybe
try
after
one.
you DQ, you might want to display one more time.
Okay.
Or okay, you can include something else. Okay.
Yeah, that's the other
Well-
error that I was receiving.
Well, now you're trying to chain after the method called DQ. Does DQ return self?
No.
No,
it
right?
did not.
But DQ.
Oh, okay. So anything after, okay. So in every chain, like
Yeah, if you
each
want to chain it.
and before has to return self.
Yeah, but in this case,
So it's is that sort of like passing a baton kind of thing?
yeah, it's like passing back the object that was calling the method. So that remember, only the objects can call the method. So yeah, it's passing the batons kind of. But right now, the DQ method, the way it's supposed to work, it's supposed to return either the value that got DQ'd, or if there's nothing in the queue, then it's just going to return none. So we don't really want to chain after DQ. So
Okay,
but
got it.
yeah, you could just do dot. Just you can do the display and then in another line of code. So scroll down.
Okay, so DQ should always be the last function.
Yeah, after you DQ, go on a new line and then do like q1.enqueue17.display.
Oh, okay. So you can just like do like something like this.
Yep. Get rid of that dot after DQ on line 67. So you don't
Okay.
get there. Cool. And now let's see if it works.
Yep,
Cool.
that works.
Awesome.
Cool. Thank you.
No problem.
Cool.